Hello everyone, welcome to a new set of tutorials from Arcanine Game Studios. In today's tutorial, we're going to show you how to create a procedural landmass in the Godot game engine. Now, if you can see, I've already created this terrain here. It's completely procedurally generated and it's using a custom shader, which I will be explaining in the next tutorials. This is completely adjustable using these parameters that I've exported from the code. So it has view distance. You can adjust the view distance any way you want. You can adjust the height, you can adjust the seed values and everything. And all of that updates in real time on the screen. You can also save this terrain if you like this. You can just select the terrain here and go into this section and save it if you want. So now that we've shown you the terrain and how it looks on the screen, let's go into the render. Let's go into the code. Okay. So the first thing that you see here is the tool directive. It tells Godot to run this script on the editor as well. This is necessary to see the changes in real time in the editor. It's a simple script that extends the spatial node, and then here are all the export functions. So for each and every one of these export variables, I've also created a custom setter which clears the node, reassigns the value, and reinitializes the node. So let's get down to it and see what the clear function does. What the clear function does is it checks if it has already been initialized, and if it has been initialized, it says that it's no longer initialized and clears the mesh by setting it to null. And what the initialization does is it checks if it's already initialized. If it's already initialized, then it returns. Otherwise, it checks if the block map is null. If it is null, it returns. And then, it does all these checks if the mesh node is available or not, and then generates the noise function and generates the mesh. And then finally, assigns initialized to be true. Okay, so let's go and see how the noise is being generated. So we're storing this in here. It's an open simplex noise. We're adding the seed, octave, period, lacunarity, and persistence to the exported variables so that we can adjust it from the editor at any time we want. And that's just it. That's how you generate the noise. Okay, so let's go into the mesh generation. What we're doing is we're generating the vertices, the UVs, the indices, and the normals first. And then we're assigning that into an array mesh. We assign all these different variables using an array of data, where we set the size to be of the maximum size defined in the array mesh data array. And then we add the vertex array, the UV array, the index array, and the normals array. Finally, we tell Godot to render a surface from the given arrays using the primitive triangle strip drawing mechanism from OpenGL and the data arrays. Okay, so let's go into how we're creating these vertices, UVs, indices, and normals. So as for the vertices, it's just a simple array of x by y. So we're initializing the array, creating an offset so that the entire terrain grows from the center outwards. And then for x in range of view distance plus 1 and for y in range of view distance plus 1, we find the height from the noise value. The noise map will give you a value between -1 and 1. We multiply it by the given height and we add the vertex. Now, the reason we iterate this from 0 to block size plus 1 is that when we're talking about the visible block, we're actually talking about a grid of n plus 1 vertices. So for a view size of 1, we need to have at least a 2 by 2 block of vertices. For view size of 2 by 2, it has to be 3 by 3 vertices, and so on and so forth. The UV is exactly the same as well, but for UV, we increment from 0 to 1 throughout the entire length. So first I create an offset, which is 1 divided by the view distance, and then we keep incrementing it by the offset and appending it to the UV. Okay, so now we're going to the indices. Now for indices, keep in mind that this is not a necessary step. If you can define the vertices in the order that you want it to be rendered, it's fine that you don't use the indices. But using the indices helps optimize the draw call to OpenGL. So if you're going to the indices array, you initialize the array, you loop the array for view distance plus 1 into the times of view distance. Now this is because we want to skip the last row. That's because on every iteration, we're going to add the index and the immediate next index in the y-axis, or the immediate next row's index. So for this, we're adding index and index plus view distance plus 1. Now there are some special indexes that we need to add every time we are done creating one row, and these are the degenerates. Now the degenerates are a special kind of triangle which are not drawn by OpenGL, but they help to connect one row of vertices to the next row of vertices. Going into more details into how this works is beyond the scope of this tutorial, so we'll skip it at here. But every time we're done completing one row, we'll add the last index of that row with the first index of the next row, and we continue the loop on and on. Now, after this is done, we're going to start generating the normals. Now for the normals, we need to have another array of the size of vertices, and I'm initializing this to point upwards. Now for the normals, what we do is we start from 0 and we iterate through the entire index, and we add the normals in 3 steps. So what we do is we take these 3 index values, which defines which vertexes to use. We check for degenerates. If they're degenerates, then we skip this. If not, we continue. If not, we calculate. So these are the 3 vectors, or the 3 vertex positions. From here, we calculate the tangent, which is c minus a. We calculate the bitangent, which is b minus a. And then we finally generate the normal, which is tangent cross bitangent. And then we assign the normal to all 3 vertices of that triangle. Now notice I'm adding these values. This is because I want to have a smooth normal. So every time I keep adding values, they will add up to something which is larger than a normalized value, but they will be smoothed out. So I'm adding this to create smooth terrain, and then we normalize the values, which is a simple loop. So once I've done this, we go back into the mesh generation and we return the generated mesh. Back in initialization, we assign the generated mesh to the terrain, and that's it. You have a beautiful terrain generation ready and good to go. In the next tutorial, I'll be focusing on how I've made this shader. It's a custom shader which allows you to define different colors for the terrain based on, it's a custom shader which allows you to define different shadings or different colors to the terrain based on the height and the slope of the terrain. But that's something for the next tutorial, and I hope you like this tutorial, and if you do, please feel free to click like and subscribe, and I'll see you on the next tutorial.